Prime factorization is the process of rewriting any number as the product of prime numbers. Essentially, this means taking a number and separating it into as many equal groups as possible. For example, the number 18, represented by these 18 dots, could be divided into 18 groups of 1, but that would be boring. 18 can be split into 2 groups of 9, and 9 can be split into 3 groups of 3. Now 2 and 3 cannot be divided anymore, and thus 2 times 3 times 3 is the prime factorization of 18. Next, try the number 7. 7 cannot be split into 2 equal groups, or 3, or 4, or 5, or even 6. Thus 7 is a prime number because it cannot be split into any equal groups at all. This animation reveals the prime factorization of a given number. For example, 6 is 2 groups of 3, or 10 is 2 groups of 5. The number 13 is prime, so it is just represented as 13 groups of 1, and so on. Now, when looking at the amount of prime factors a number has, you may notice something interesting. 2 has 1 prime factor, 3 has 1 prime factor, 4 has 2 prime factors, 5 has 1 prime factor, 6 has 2 prime factors, and so on. It seems that the majority of numbers have an odd amount of prime factors. Looking at the numbers from 1 to 50, 30 numbers have an odd amount of prime factors, and 20 have an even amount. One might ask the question, is there ever a point in which the majority of numbers have an even number of prime factors? This was first asked by George Poyat in 1919 when he conjectured that for every number, the majority of numbers less than it would have an odd number of prime factors. He had a good reason to think it was true because looking at every number less than 1,000,000, this statement was true. For about 40 years, mathematicians tried to prove it was true until 1958 when Colin Brian Hasselgrove proved it to be false. The number 906,150,257 is the smallest number in which the majority of numbers less than it have an even number of prime factors. This is remarkable because the conjecture was true for every number up until this massive number. This is an example of how mathematics can be surprising and produce unexpected results that take years of work in order to learn new things.